Hi guys, I'm going to speak about Agile, about measuring Agile processes. And okay, let's start. Let's start with me, that's important. My name is Łępicki, I come from Poland, I come from Białystok. This is my email addresses. This is my GitHub account, and you can find me on Twitter, on my updated blog, so you can find me in various different places. This is the place that I came from, so quite close. And I'm a Rubyist, so I love Ruby. And I run a small company called Hubert, and we are focusing on developing software with Ruby and Ruby on Rails. And we're awesome. As you can see, we are a small team and quite messy environment to work in, but it kind of works. And as I said, I'm the boss. So what I do is every day is this. Agile. We just heard about the Agile. I'm going to talk a bit how do we implement Agile, Scrum and Kanban in particular, in small team. Our team is 6 people altogether right now. It used to be a bit bigger. Now it's 6. First question is why? Why do we focus on Agile development? The only possible question is to build a bit better software. And using Agile allows us to control chaos and go the other way. This is actually the most important, to keep our clients satisfied. And unless your clients look like this, the only way of keeping them satisfied is actually to build great software. So alternative title of this presentation could be How to Build Great Software, or How to Run Successful Ruby Software Development House. So the Agile and Ruby, you all probably heard the Agile term or read it from the cover of this book. This book doesn't have much to do with the Agile development. It's all about the Rails. Anyway, that was titled like this. The real Agile principles, you can find them on agilemanifesto.org website, and they are quite simple. There are a few most important parts, which I'm going to show to you. Individuals and iterations over processes and tools. So the individuals and the communication between these individuals is the most important part of the process. Working software over comprehensive documentation. So we are software engineers. We are building software. The documentation is less important. Customer collaboration over contract negotiation. And responding to change over following a plan. So you might ask yourself, no process and tools, no documentation, no contract negotiation, and no plan. How do you do this? How do you guys do it in Poland, in small team? This is wrong. Obviously, there are contracts. We sign contracts with clients. We negotiate them. Our contracts are simple. It's just 1 or 2 pages. And flexible. The client doesn't have to work with us if they don't want to. They focus on service over the product, so we deliver our client's services. We don't sign a contract that we will deliver a working product. We're just delivering the service of building it. And we negotiate our rate. And our products should have documentation, which should be readable. And obviously it can be in form of tests. Good written tests are very good documentation. It also can be in form of code. So well-written code, easy to manage, easy to read is also a form of documentation. That's also something to remember. And there must be a plan. What about the plan? How do we stick to the plan when we have the Agile process? It's actually quite simple. When we have estimated user stories, we know what the user stories are. In the product backlog, when we use sprint, and we have the team velocity is known, so we know how much story points or hours of product can our team deliver in one iteration. We can predict when we can finish, and that's the plan. About the process, the Agile processes are well defined by the methodology. It depends on the methodology that you use, and also these guys from England talked about adjusting this to your environment, to your development team. That's also very important. But it's very important to stick to those rules, so you don't change them during the process unless you have to. One of the methodologies is extreme programming, which sounds a bit like it's old, but I'll show you a bit. The other one is Scrum, and you might have heard about Kanban. And there's also a thing called Crystal. There's a few flavors of that. Nobody really knows what is this. So just what do they have in common? These are iterations, and even the sequential development, like Kanban or Scrum, should have iterations, because you find iterations in Agile development everywhere. If it's Kanban, if it's Lean, your iterations are release cycles, so you have to see the goal where you're going to. You also find iterations in your daily routine, so you have stand-up meeting in the morning, then you sit to your computer and you have more iterations. So like you start writing code, actually start writing tests, then your tests fail, then you're writing code, then you're implementing, and and then you're doing it again. So these are iterations. Incremental development. You do one thing at a time, because I don't agree with the first presentation that a man can do 4 or 5 tasks at once. They can do one. And they have defined roles in projects. So different people do different stuff. What are the differences between these methodologies? Extreme programming is all about the engineering practices. It's about test-driven development, it's about pair programming and stuff like that. Scrum is focusing more on project management. Actually, if you get a book about Scrum, you will not read about pair programming or other stuff, or if you read, it's additional. It's all about the process. It's how to manage the project from a bit more traditional project management perspective. And Kanban and Lean, these are fast delivery of features to the client. So our practice at Ambibit, we use Scrum, we also use Kanban, and we use some extreme programming techniques that we find to be the most useful. And when it comes to Scrum, for us it's good for the longer projects. These are projects that take a month, at least, so 2, 3, 4, 5, 6 months. We do 2 iterations. We find we tried longer iterations, like 3 or 4 weeks, and we tried small iterations, like 1 week. 1 week is not enough because there's too much planning involved, and meetings, and retrospectives, and this just takes a lot of time. 4 weeks is too much, because then it's, I think it's called procrastination, that the team doesn't see the end of when they have to deliver and close the features, so they are being lazy, people are lazy. And Scrum has got very simple rules, so it's easy to teach Scrum. But actually Scrum is hard. And I find Scrum to be the most hard for the clients, not actually for the team. Clients do not understand, for example, that you shouldn't interrupt team with new features during development. If you have this problem with your clients and you cannot find them, it's better for you to go with Kanban. And Kanban we use for small projects. If there's a website to build and or something that will take 2 or 3 weeks or a month, Kanban is very good for that. It's about instant delivery of features. We saw that if something is done, it can be deployed very, very quickly on this, if it's on the Kanban board. And it's easy to understand for the clients. So clients are beginning clients that begin with Scrum, in my opinion, are easier to be convinced to use Kanban than Scrum. We also switch to Kanban when a big project goes live. So when we have a project that we built for a few months and then we release it, there obviously will be some bugs, some things that you must fix that immediately and stuff like that. Scrum is not very good for that because all clients you have to wait 2 weeks for deployment. Kanban is perfect. Kanban also, actually both, and Scrum and Kanban in our implementation, they both encourage client, actually they require client to work with us. An average client spends about an hour or 2 hours working with a team daily. So it must be a dedicated person to this task to manage the project from the client side. If there's, that's interesting, if there's no client, if client cannot give a separate person to manage the project, we suggest that the client hires someone and we point them at this person, which is not part of our team, because to avoid the conflicts of the interest, that must be a representative of the client. So we say, go and hire this independent manager and he will be your representative. That works very well. And about extreme programming, it sounds like an old thing. I have a pile of IT books and magazines from the 90s, and they were all about extreme programming, and I was thinking boring. But actually you use it every day. If you use Rails, if you do proper development, with behavior-driven development, with a spec or test-driven, whatever you call it. If you do pair programming, you do extreme programming. If you coach your co-workers, you do extreme programming. From these methods, I find pair programming very good. That's really valuable, especially when you work with developers that are a bit less experienced than you, because they learn from you. But it's also quite expensive, and it's slower because in short term it's slower because just one people is working at the time coding. But it got very good results in terms of quality of code and especially quality of tests. In extreme programming, there's rarely used, but there is that tracker role. So this is the person that actually tracks the project. So this is something that's not in Scrum. This is the designated person that will keep an eye if the project is going the right direction and we're going to finish it on time. A lot of companies, at least in Poland, use Agile with Ruby. And why? Agile processes fit object-oriented programming. That's not only my opinion. That's actually the extreme programming was invented to support Smalltalk. Smalltalk failed, but extreme programming survived. They have simple rules. We like simple rules, and they can reduce the code through chaos. I think that's popular. Yes, sometimes projects fail, even despite trying to implement agile methodologies, and things can go bad. How bad? For example, I used to work on a project that was in London, and we worked for a company that was finished a project in October 2007. We finished in October, but 2008. So that's quite bad. And obviously that was before my company was founded. We're much better than that. Who is, or what is to blame for failures of your projects? First thing to look at is bad programmers. That's something not to forget about. If your programmers are bad, using agile techniques will only expose their weaknesses to the client and to you, so you will realize how bad your programmers really are. Unless, well, there are some techniques like pair programming that will possibly make them better in the future, but in the short term, you will realize how bad they are. So, this is not a silver bullet for this issue. Bad management, and that's the point with usually big companies. And oh, fuck. Click cancel. Cancel. One more time. Okay, cool. Bad management can kill any project. I worked for a project that's quite fun actually. That was a project for a band, and the band was hoping to engage their fans by sending them videos and photos from their concert. And there was the manager of the band that was the manager of the project. And apparently we did the website, we did the software. It was working, it was great. But then they realized that you cannot take photos and you cannot take pictures and films on the concert. So this is an example of extremely bad management. And wrong implementation of agile methodologies. If you want to know how to do it wrong, just visit this website. And it gives you very good description on how to do it wrong. If a project fails, you usually want to know what went wrong. And if during the development you want to know if things are likely to go wrong or you're good. So you need to somehow measure the process. The question is how? And it's a good question. And if you get the books about Agile, there's all about the rules and all about how to do it, but not actually how to measure it. The only way they show it is usually the burn down chart, which is not enough. XP, there's a tracker in Scrum or Kanban. Who's responsible for that? That answer for this is quite hard, but it depends on your environment. In our team, that's a Scrum Master who's responsible for the project. And the question is, are we doing it right? Maybe. And could we improve our process? That's for sure. Because Agile is like communism. I don't mean shared code ownership, which is, by the way, great. But you constantly build it. You know, they built the communism for 50 years, and we build agility, trying to build agility more and more over the years. And there's never going to be an agile heaven. It's utopia. I don't know how it's in English, but it's a dream. But opposite to communism, implementing just parts of it, or trying to implement it more and more, works quite well and brings good results. And nobody got killed, so that's also good. Let's think what can go wrong during the project. That's obviously wrong implementation and communication problems and software quality, which can get worse and worse over time. And obviously that's the worst thing for the clients, that we don't meet budget or scope or time. What to measure? First thing, which is really important, and a good issue tracker can help you with that, is the team velocity. For example, Pivotal Tracker does it quite well. Team velocity is the number of, for example, story points that they can do in one iteration. or you can define it a different way. That can be hours they can do, or it can be numbers of story points they can do one day. From my perspective, it's quite important to measure project size, so you know how a project is growing in terms of lines of code. Progress, so if you have a lot of stories to be done in a project backlog, you need to have a look if the number of them is going down. So if you're likely to finish this project in a reasonable time. Last thing is quite interesting. A value of one story point in time. You can have a look during different iterations. And for example, if your team estimated a feature for this number of stories, number of points, you can have a look then in your time tracking system, how much time did it actually take? Because sometimes there can be this symptom of so-called story point inflation. So the team starts to overestimate because they failed to implement the features in the past. They start to overestimate and overestimate them, and then you end up with less features in the product backlog, but more estimated, and that's quite bad. Number of passing failing tests. Code complexity, I find it very interesting and very important. Code coverage of your tests, to how much code is run, and test to code ratio. What are the Ruby tools? Let's think about Ruby. I'm going to show some Ruby, simple, pretty basic stuff. Well, you can. The first thing is your issue tracker. Your issue tracker is your friend. If it's a good one, it will help you. For example, we've shown you the team velocity. You can use Ruby because you're familiar, you're Ruby developers. I'm a Ruby developer myself. Continuous integration builds. Are you also friends? Let's talk project size. This is probably the simplest way to get the project size. If you Rails, it will display you the simple table, text table that will show you how many controllers, classes, methods you have. It will also show you code to test ratio and number of tests. So you have that. So you have that data over here. You can write your own. If that's not that you're looking for, you can write something like this that will iterate over the files and count the lines of code. Simple. And the project size can grow different ways. This is from one of our early projects, and it was growing just like this. So you can see that this is almost constant growth. And at the end of the project, there are, well, you can see the releases when the project size goes down and the new implementation cycles. So that should look like this. Test results. In ideal world, test results should be all green. Everything should be green all the time, especially when you push something to continuous integration at the end of the sprint. But you can collect these numbers, and if things are not going well, just use your continuous integration server. Okay. When you use RSpec like we do, to get this information without continuous integration, or if your continuous integration doesn't provide this way to get this information from RSpec, you can hook into RSpec code and just something like this. It will provide you the number of failed tests, passing tests, and also provides you the time of how long it took to run the tests. That's something I didn't measure, but that can be quite interesting as well. And test results, these are some test results. The green ones are passing tests, the red ones are all the tests, and the blue ones are failed. Probably not very good choice of colors, but you get the idea. And your number of tests should be growing with your code. That's obvious. It can be reduced at some points. That's because if you do refactoring, you also should refactor your tests. Test to code ratio. That's quite bad actually. So let's skip it. Code coverage. There's a Ruby tool that's called RCO, which will show you the code coverage. Code coverage is good because it shows you how much of your code was actually run during the tests. With rates, you can just run this and view this page that will give you the results. And code complexity. That's something I find very interesting, and if you've been to RubyConf, there was this girl from Belgium, I think, talking about static code analysis. Why do we have to bother with that? I found that code complexity is the only measure of technical depth that you can actually get from your code, because in automatic way. So you can measure complexity of a code. How does it change over time? And you can detect that, for example, the client is pushing too hard new features, so that the complexity is growing. The team is not doing very well job. So you have to step in and say, sorry, client, we have to do some refactoring because we will suffer in the future. Yes, and obviously this is a measure of technical depth. Technical depth is a very bad thing. This is something that you're doing just to make this program work, and then we'll fix it later. You never fix it later unless you actually do the proper refactoring. So static code analysis with Ruby. I'm going to show you links to two quite cool programs. First thing is Flog, and the other one is Sekuro. Not sure about the Sekuro, but the Flog is written by the Ruby Studies, so guys from Seattle. And Sekuro, it's possibly from Japan. They use a bit two different techniques. Flog uses a metric called ABC, assignments, branches, conditions, and Sekuro uses psychomatic complexity, which is a bit more complicated, but in my opinion, they both work. Unfortunately, these are Ruby 1.8 only, so I tried to run them. There are some forks, and it's even possible to get some results for some 1.9 code, but it failed for my real projects. So I wrote a simple gem, so you can get it from here, that calculates metric ABC. That's only 1.9, because that was simple. And you can run it on your project. Just give it a list of files, and it will give you the results. So this is the file, this is the class, and this is the function. And on the right, you have this complexity in points that it gives you. Basically, what it does is just calculates the number of assignments, branches, and conditions. Branches are function calls, process calls, and stuff like that, and divides that by number of lines of code in that method. I think so. And you can calculate average code complexity of your project. But if you do it in linear way, so that you just calculate the average code complexity of every single function, and then you will have some huge functions, and they will be gone in this metric. So you just cannot rely on this diagram if you just do linear calculation. Yeah, just that. This needs to change to show you the pain of using your code or changing the code. So I came up with something like this. So I just take the y is the average complexity of the I function number I in your program, and this is the exponential function that calculates it better. It gives quite nice results. For example, here we have after first release, we had some period of cowboy coding, which was very bad. It took 4 weeks without nothing. And you can see that we were punished by very high code complexity, and teams spent next iteration just to fix that. You can, with Ruby also, you can for example measure how your team is trying hard, how hard they are trying to do things by just calculating number of lines of code changed daily. There's a, for example, if you want to calculate different metrics from your Git repository, the grid is the greatest Ruby library. There's my fork on the GitHub also that has got some extra features that not yet available in the official repository. But in a project, in this given project, it looked like this. And probably the pain of implementing new features was growing, and but also the project at the end was just coming to the end, so there were not much new features coming. So that's why it's slower. But you don't have to, cannot forget about burn-down charts. Burn-down charts are great for Scrum and everywhere where you have iterations. So in this example, this is my own tool to do burn-downs. I like it because it shows you how what's the ideal, what's the estimated velocity of your team during this iteration, when are you likely to finish your iteration or all the user stories. This is a graph that I found very useful also. If you have estimated story points in your product backlog, you just plot this, and this gives you, this, I think some people call it the burn down of sprints. So you measure how many remaining points we have at the end of each iteration, and you just have to look at it if you're going in the right directions. You can also plot these lines that I showed you, so estimated and the best. That's very good. How to plot this? I just used plot, so this is very easy. You can build something else. It's very easy. You can hack it just to have a look how it works. And this can help you, but don't forget that measure of success is the working software. So the only thing that really matters is the working software. And the metrics can lie. It's if people try to lie, for example, code complexity, it's easy to cheat on. Just split your complex function to, as well, easy, hard to understand, but smaller ones, and it will be cheated. And you need to adjust that to your techniques. You need to find your own way. What I find very important is not to introduce more work to the programmers, because they should focus on programming, because that's what they do. And so you have to do this for them. If you're a Scrum Master, then it's probably a good idea to do it. This helped us to realize that it's better to stick to the rules. We saw some examples how not sticking to the rules of Scrum, for example, increased the code complexity and technical depth. That was just punishment for our bad behavior. Yes. For example, little changes make great difference, and we learned that it's hard. So that's all. Thank you. Any questions, please?
Hello, my name is Hubert, and I have one simple and maybe a dumb question about Agile methodology. I can't understand one thing. Why do you use story points instead of using hours? So you estimate a user story in story points, and then you have to somehow calculate how much hours it will take and how much data it will take. Why don't you use hours instead of story points? Thank you.
When we started implementing Scrum about a year and a half ago, or maybe a bit earlier than that, we thought that this is a bad idea to use story points. We read it in books, and we we try to go with the estimations in hours, but they tend to be not very accurate. So if the estimations in hours are not very accurate, why to use them? And that's one thing. The other thing is that the story points. Well, the thing that we do with story points is that in each project we have like reference stories. For example, two story points, this is this little story. 8 story points, this is a bigger one. 16 points, this is something even bigger than that. And this helps to like think about complexity, not how much time it will take. And I don't know why, it just works quite well. So just try it. Try one thing, try one other thing. Maybe you're better at estimating the hours than we are, and that will be just great. But yeah.
Hi, my name is Jaroslav. I want to ask you how big the projects were that you were guys working on in terms of scope, traffic, users, database size. So how big the projects were that you were working on all the Agile techniques. And I would just like to thank you. It's quite a nice presentation.
Okay. The projects are vary. For example, some big projects took 6 months to develop. I think that was the biggest project that we did with Scrum, was 6 months project. In terms of traffic, it depends. These are not like these guys we were talking about yesterday. These are not huge applications for massive traffic. We usually do more specialized, a bit less traffic websites and applications for industries. We also do a lot of internal applications. So these are not published on the internet. So these are intranet applications for companies. For example, we did very big. That was actually more than six months. That was about 12 months. Printing system for a company. So this is not very high traffic, but it's very specialized. So it generates PDFs and print quality stuff. So we're not going to the volume. We don't have much. Well, we have some, but this is not focus of our projects. Does it?
Hi, I'm Łępicki. I just wanted to ask about the rules of defining the points quantity for each story. So why to limit with 8 points in sprint planning?
Okay. The answer is, well, we use the scale of points that are 0, 1, 2, 4, 8, 16, 32, and 64, I think. And developers like it because it's cool. It's powers of 2. It's really up to you. But the important thing about it is that this changes. If the developers think that the feature will be more complicated than another, should be greater than the step back. Because we tend to, as a people, we tend to underestimate the complexity in hours, for example. We just say, but if we assign more story points, that's more likely to happen, because when it's more complex, it's likely to take more time just to do it. And how do we decide if one story point is number 2 or 8 or whatever? Actually we do it for different. At first planning meeting, we just choose arbitrarily what we think is right, and then we compare that stuff that we did. For example, that we estimated that the previous user story for 2 story points. In the following iterations, we refer to that to compare that. This is similar complexity, so this will be 8, or this will be 16, stuff like that.
I have another question. So you were saying that you guys use story points up to 32. Pivotal guys actually push the usage up to 8, and they ask you, they kind of advise you to use very small story points so that you don't get into stories which are really huge that will take you weeks or something like that.
Yeah, so that's true. We use this high number of points when we have to estimate something that's in the backlog that we don't have complete idea how it's going to be done. So we need to do some more research on that. So I don't know if it's a good practice, to be honest. I need to think about it. But it's usually up to 16 that normal stories that we have in sprints take. If it's more than that, it's likely to be split into something else. But if the client, because the clients sometimes enter huge user stories into like epics into the backlog, and we have to split them later on. But for example, to estimate them, you just choose bigger ones.
Any question? Okay, so
cool. Thanks guys.
Thank you. And now we will have the